Now we want to look at our second order partial derivatives. So typically, looking at our notation, our standard second order derivative we write as d squared by dx squared of our function. Likewise, our prime notation is f double prime of x. So we want analogs for this now with our partial derivatives. Our analog of d squared, very straightforwardly, is just partial d squared with respect to x squared of f of x, y. However, we can also take partials with respect to y. So we can also get the partial squared with respect to y of our function. Another thing that we can do is we could step in the x direction and then step in the y direction. So we could get the partial with respect to both x and y. One thing that we'll see is that this is the same thing as if we were to go y and then x. So it doesn't matter which direction we go, we can go xy or yx. Cool. I'm going to do a much simpler example this time because the last example got really long. So we'll look at an example of doing this. How about 3x squared y cubed? It's a really straightforward example. Cool. To do this example, I'm just going to take the with respect to x, with respect to y, and then go through the other variables. So the first derivative with respect to x is the partial with respect to x of 3x squared y cubed. I can bring all of the non-x stuff out. So this is 3y cubed partial with respect to x of x squared, which is going to be 3y cubed times 2x. And then I can simplify it. 2 times 3 is 6, x, y cubed. Because again, our convention is number, first variable, second variable in alphabetical order. Cool. And then our partial with respect to y is the partial with respect to y of 3x squared y cubed. We can bring the non-y stuff out now. So that's 3x squared times the partial with respect to y of y cubed. That's 3x squared times 3y squared, or 9x squared y squared. I'm going to write these to the side so that I can then take the second partials. Cool. So now I've got fx and fy, and I can take their second partials. Cool. So my second partial with respect to x, this is the same thing as the partial with respect to x of f of x. So this is going to be the partial with respect to x of 6xy cubed, because our first partial was 6xy cubed. We can pull the non-x stuff out. That cube is on the y. That's going to be 6y cubed times the partial with respect to x of x. The derivative of x with respect to x is simply 1, so I'm just left with 6y cubed, my apologies. Cool, and I'll write that over here. Cool. Now I can find the partial with respect to y. I'll say fxy, which is the partial with respect to y of fx. It looks like it's out of order, but think about it as this is the partial with respect to x, and then we take the partial with respect to y. That's what we're doing. We've already found the partial with respect to x. Now we're differentiating with respect to y. Cool. So that gives me the partial with respect to y of 6xy cubed. We can pull the non-y stuff out. So this is going to be 6x times the partial with respect to y of y cubed, which is 6x times 3y squared, which is 18xy squared. So I'll write that over here. F sub xy equals 18xy squared. And then I'll find fyy and fyx. And we'll see that fyx is the same as fxy. So fyy is the partial with respect to y of f sub y, which is the partial with respect to y of 9x squared y squared. We can bring out the non-y stuff. So it's the partial with respect to, or I should bring the stuff out first. That's 9x squared partial with respect to y of y squared, which is 9x squared times 2y, which is 18x squared y. And I'll write that right here. Fyy is 18x squared y. Looks really close to our fxy, but it's not quite the same. And then we want to find our fyx. That's the partial with respect to x of fy, which is the partial with respect to x of 9x squared y squared. We can bring the non-x stuff out now. So that's 9y squared partial with respect to x of x squared. And then the derivative of x squared is 2x. So 9y squared times 2x, which is 18xy squared, which we see is exactly the same thing that we had here. So that's all of our second order partial derivatives. We get first one, or the first one, second one, third one, and then the fourth one. There's technically 4, but 2 of them are the same, so we don't have to worry about it, which is really convenient. Next, I'll show y'all what necessarily is the reason that we're doing this.